Let's do this. 4 different complexes can be obtained by reacting aqueous cobalt 3 chloride with ammonia under various conditions. Different proportions of chloride are precipitated when each of the complexes is treated with aqueous silver nitrate. So what is the context in the first place? The context is, let's understand a few things first, right? That all of these, what are they? They are your complex ions, all right? Or rather, not complex ions, say around it. These are all your complex compound. They are complex, right? So let me get my pen out once again. They are all your complex, right? They call them themselves complex. And again, this complex was due to what? Due to the cobalt 3 chloride aqueous, right? What I want to focus on is here. I know that this is the central metal transition metal ions involved. That's the first thing I want to appreciate. And whereby the ammonia then come in, all right? Okay, and then you'll go inside there, right? One way or another. And then they form this complex. A complex itself, if you still remember, all right, which is neutral complex, is a compound. You say neutral complex, you can say is a complex compound. It's always made up of 2 things. Makes up of the complex ion. Right? This was what I've been trying very hard to run through twice. Because people are confused why the complex come out 2 times. You need to appreciate it comes out 2 times. Right? Then you have this thing. What is the other thing that I taught? Sorry? Very good. The counter ion. Right? Counter ion also known as free ion because it will free themselves out. They are just there to like something like spectator ion, just to balance out, to get the neutral compound. All right, so be very, very clear. So very smooth one, cannot have doubts. Then from there, then we can play. Okay, so okay, done. So the whole idea is right now they will always have what come out. They will always have, let me use the blue color, free ion or counter ion that is floating around. They are mobile, they are able to move. They are out there, they are free. Okay, so what? So then we always tend to use a precipitating agent. Who's that? The favorite one, right? Silver nitrate, barium nitrate, barium chloride. So silver nitrate AgNO3 contribute these 2 ions. The whole idea is this ion will react with your counter ion to form the precipitate. And what is it? Obviously, your chloride, right? So Ag and Cl minus. Ag plus and Cl minus will form the precipitate AgCl, solid, which is what they say here. Done. That's easy. All right. So they have a lot of this kind of question. Basically, AgNO3 is a test for the mobile ions. Also, I mean the free ions, the counter ions, to be more precise. Okay? Cannot make sense? All right. Make sure we have the idea first. Okay, done ready. Then I'll shift this up and we can solve it anytime. Now. Okay, so here we go. Based on the number of complexes, if you don't mind, I change it to green and pink, easier for me to see, right? So just a moment. Here we go. Number of moles of AgCl precipitated per mole, all right, of this ion. So here we go. 3, 2, 1. All right. So if you allow me, let me just quickly write it out. All right. So I'll just call it complex A. This one, it won't block me. So I just write here. Immediately, how does the complex look like? What they give you is like empirical formula. They condense everything together. All right. So based on the green color information, I think it should look like this. So cobalt 3 plus ion. Number of moles. All right, so I'm looking at this once again. This should be a 6, I believe. And then this is a 3 plus. This is a 3 Cl minus. Why? Once again, take as a green color. Every one more of this blue will give you 3 moles of AgCl, which is from 3 moles of Cl minus. All right, mole of Cl minus to mole of AgCl is 1:1 ratio, right? So that represents it very clearly. Okay, done. So I'll do likewise for the other 2 and just match it up, and that's it. We get our marks. So complex B. All right, what is the complex compound? It has 2 moles, so it must have 1, 2, 3, 4, 5. and then your 3Cl. Again, look at we're looking at the second one, all right? And then 3Cl, two of them are your counter ions. That's it. All right, again, 2 more is here, 2. All right, so the last one, here we go. Complex C. Now I have 1 more. And based on the formula, once again, take a look. They already help you already. This is Cl2. Again, most structure, geometry are octahedral. So the central metal ion, we have so-called 6 coordination number 6, right? I.e. 6 ligands of charge. NH3 and Cl2, they're all monodentate. All right, consider done. All right, I hope everyone agree with me. So this is your, again, this 2 plus, this is plus, and then Cl minus. Done. Okay. Again, ABC, the formula they have written out, all 3 complexes. If you go back to the empirical formula, it fits them nicely. All the number tallies. All right, then we have to look at A and B. All right, this one and this one. They say number of possible structures is 1 and 1, right? Each of them only 1. It makes sense. Once again, octahedral. So again, everyone, you've got to visualize. Ask yourself, all right, for complex A and B. A is quite straightforward. Let's take a look at B, all right? So if this is only 1 Cl, right? So if I put a Cl here, the rest are NH3. All right, let's do dash, dot, dash and wedge so you can see very clearly. Please, based on the octahedral structure, turn the molecule around. Hope you agree with me. No matter what, there's only one way of drawing it. Whether you put your Cl here or your Cl later, you flip it around, say to this position, they are the same molecule. There's no other way of drawing A and B. Current one I drew is A. So your Cl can go to, right, this thing, right, can go to any of these positions, any, right? You have to move the molecule, they are the same molecule. Based on the 6-point charges, all right, that 1 point that is different, no matter how you move it, all right, turn it around, it's the same thing. And that brings us to C, whereby there are 2 structures and it's a little bit more fun. How come you have 2 structures? Someone, we are looking at what? Isomerism. Okay, it's always like that, right? More than 1 possible structure, isomerism. So what kind of isomerism are we looking at? Sorry? Cis-trans isomerism, okay? So again, let me have a bigger space. I'm going to draw for you to have a look. All right, standard question nowadays for this type of question. All right, so here we go. Let me draw properly. I'm going to draw the 2 isomers, the cis and the trans, and I will draw 2 forms of it. Because one form, if you are drawing it, is very straight to the point. The other form, whereby if it's given MCQ, that's the one that people always get tricked. So I'm going to draw both presentation for you to see. Okay, so once again, complex C. All right, so let's jump in very quickly, write out the formula, don't mind. Okay, so here we go. The cis and the trans. Okay, so I draw the easiest to see molecule. So here we go. Let me have a space here. Again, it's good to do dash and wedge because you can see them quite clearly. All right, so this is the one I want to see. I mean, I want to design, all right. So this is the cis. Okay. Sorry, this is not very friendly these days. All right, H, ammonia got 4, chlorine got 2. All right, so this is the cis, and then let me draw the trans. What's the best way for me to show you the cis and the trans? I think I will draw it this way. Okay, let me draw a line to split them across. Give me a moment. Okay, once again, where is the cis-trans we are looking for, right? So once again, if I'm the one, i.e. paper 2, paper 3, I'm in control. This is what I'm going to draw, because it makes sense, right? Same side towards you, cis. Opposite each other, trans. Everyone okay? Can one front, one back. So this is trans, very straight to the point. So if the one drawing in exam, I will draw this. In MCQ, they will not show like this. Instead, they will show it in a way that is not so straightforward for you to see. So I'm going to draw it in blue, right? It's the same cis and trans that I'm doing. Once again, right? So how would they draw this? So the trans over here. So in exam, MCQ especially, you will see something like this. Remember, MCQ technically is not difficult, but it gets you confused because of the way they try to present it. Because every time this type of question, right, if especially MCQ, it always kind of slow me down because I can't see very well. So I told myself, okay, actually, what's the problem? Let's take a good look. Okay, I draw one of the thing wrongly, so I have to change. Sorry. Ouch. Not very happy with Zoom. Okay. All right, they'll draw this one. So take a look. Those are very good with your spatial, i.e. your 3D. Congratulations. Those that are not, please train yourself to see. Okay, done. Correct. Check the groups. All right, so the blue one is the one that will high chance come on MCQ because, as you can see, it's not as straightforward. But the blue and the black are the same molecule. Are you aware? That's my question. They are actually the same molecule. Slowly, all right? Let's not rush. Unless I made a mistake and draw wrongly. If not, should be like that. Should be correct. Yeah, so if it's MCQ, the blue structure will be probably the one that come out because some people can't see. If you'd like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you'd like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.